Hello everyone. This video will show how to write the equation of a given polynomial graph with multiplicity. Now let's go over this example. The roots for this graph, which means the x-intercept for these graphs, are these. If you notice at this root right here, which is on 3, the graph flattens and passes through. So from this point right here, it flattens and it went through. Now please remember that if a graph flattens and passes through a given point, there is a multiplicity at that root. And please remember that this multiplicity comes in 3, 5, 7, 9. So pretty much there is an odd multiplicity at this root here. So I'm going to go ahead and write that description up here. So we go ahead and write the roots for this given graph. So I got these roots from the dots that I created. These are the x-intercept. X equals -3, x equals -2, x equals 0, and x equals 3. We are also given 2 points here. So these are the 2 points. Again, please remember that at x equals 3, there is a multiplicity at that root. So I'm going to go ahead and set up the equation for this graph up here. So we go ahead and write y equals a. Then we're going to use the roots that we got here. So that would be x plus 3. Then we have x plus 2. Then we have just x. And then we have x minus 3. Again, there's a multiplicity here. So the multiplicity, if it flattens and passes through, would be 3, 5, 7. So we're going to try 3 first. So I'm going to put 3 up there. So what are we going to do next is we are going to solve for a by using one of the points that we got here. So let's say, for example, let's use the first one. This will be our x and this will be our y. And we're going to solve for a. So I will plug in 4096 on the y and -1 on the x's. And the equation would come out. So what I did was I plugged in y 4096 and all the x's will have -1. So I'm going to go ahead and simplify this equation and solve for a. So we have solved for a. Our a is 32. So the possible equation for this graph will be, we're going to use this, but we plug in 32 to a. So the possible equation would be, now we are going to check this equation whether it works for this graph. So what are we going to do is we are going to use the other point that we have here to check if this equation is right. So what we do is we plug these values in. Our x is 1 and our y is -768. So I'm going to plug in the y value and the x values to each of the x's here, which is 1. So what I did was I plugged in the value of y, I plugged in the value of x here, and we're going to determine if both the left side and the right side of the equation would equal to 768 negative. If not, then this equation doesn't work. So I'm going to go ahead and simplify this. If you notice, the left side and the right side of the equation are not equal, because we have a -768 and -3072. So this tells us that this equation that we have here doesn't work for this graph. Now, if you notice, we've set up everything right except for this multiplicity. We started with 3. Now let's try 5. So what I'm going to do is do exactly the same way here, but this time around, I'm going to change the multiplicity to 5 since 3 doesn't work. So I've set up exactly the same, but the thing is I changed the multiplicity to 5 to see if that would work. So I'm going to go ahead and plug in 4096 on the y and -1 on the x and solve for a. So after doing the math by substituting 4096 on y and -1 on x, our a value is 2. So we can go ahead and say that the second possible equation for this graph would be y equals, I'm just going to copy everything here, but the a becomes 2. In this equation right here, you can go ahead and write x after the 2. That should be fine. It's just the same thing because it involves only multiplication. So I'm going to go ahead and show the checking part here. And this is very critical because if the left side and the right side of the equation don't match up, then we move on to the multiplicity of 7 instead of 5. So what we do now is we will plug in 1 to all of the x's and we will plug in -768 to the y and see if the left side and the right side of the equation are equal. Now if you notice, if we multiply 24 times -32 is -768. Now notice that both sides of the equation are equal. This tells us that this is the actual equation for this graph that we have right here. So if you put the multiplicity as 3, it doesn't work. This is not the right equation, but instead the multiplicity for this is 5 because when we check it, both the left and the right side are equal. So that is how we write the equation of a given polynomial graph with multiplicity.